The Grigsbys present Fun with Math, starring Mr. Grigsby and Miss Grigsby. Hi guys, I'm Miss Grigsby, and I'm going to teach you how to find the segment lengths and circles. Today, the theorem that we're learning really doesn't have a name. So basically, what it means is that if two chords intersect in the interior of a circle, then the product of the lengths of the segments of each chord is equal to the product of the length of the segments of the other chord. So I'm going to give you a second to copy down those underlined green words before we move on. Alright, hopefully you've had enough time. So I'm going to scroll this up a bit so I can show you exactly what that means. So you'll notice that both of these chords, A, B, and D, C, are actually split into two segments. So EA times EB is actually going to be the same as EC and ED. So when I write that formula out, it means EA times EB is the same or equal to the product of EC times ED. So when you see this formula and this work, you're going to plug in the numbers that you see on the segments. So to give you an example of that, I'm going to show you that EA is going to equal 2, and EB is what we're going to try to find. We're going to call that X. So then ED is going to be 4, and EC is going to be 3. So I'm going to give you a moment while Mr. Davidson pauses the video to solve for X, and then we'll come back and check your answer. All right. So you've had a few moments. Mr. Davidson's paused the video, and we're going to walk through plugging these numbers in. So EA was 2 times EB, which was X. So hopefully you came up with a product of 2X. Then EC was 3, and ED was 4. So hopefully you came up with 12. So you had 2X equals 12. Now, 2 times what equals 12? Hopefully your answer, when you divided that out, was X equals 6. All right, so we're going to take that a little bit further, and Mr. Grigsby is going to show you the next steps.
All right, now that everybody's thoroughly confused as to why she's here, let's go ahead and move on. We're going to do another example, and what we're going to do is it's going to require more algebra. Okay, so that's what we're going to work on. Yeah. Okay, and hopefully what she just went over, I'll go over the same thing. Hopefully it'll make sense. Either way, whether you got it from her or from me here. So let's go ahead and get started here. We're going to find the measure of ML and JK. Okay, so in this problem, we've got a lot of x's, we got a lot of variables. Well, actually, the same variable multiple times that we're trying to solve for. So let's go ahead and see what we can do to get started here. So what the theorem that we just talked about said was that if we have two chords that are intersecting inside the circle, then we can take each of these pieces. Okay, so for example, this chord right here, ML, is cut into two separate pieces. Okay, and same thing with JK. JK is in two separate pieces. So if I take the product of those pieces, okay, if I take this times this, that has to equal this times this. All right, so that's what we're saying in this theorem. So let's go ahead and get started. We're going to try to set up an equation to try to solve for x. Okay. All right, so let's go ahead and see what we can do. So you there, you with the face right there. You with the face right there. What can we? What's the equation we can set up? Pause the video. If you said x times x plus 4 is equal to x plus 1 times x plus 2, that's correct. If you didn't say that, it's wrong. All right, so anyways, let's go ahead and try to set this up. We're going to have to try to solve this equation, okay? So this is going to take a little algebra. This is going to take a little algebra, and let's go ahead and try to solve it here. Okay, so what we can do is distribute, well, first of all, we got to distribute this x through, okay? So x times x is x squared, okay? X times 4 is 4x. All right. So hopefully that's all right. Now, let's go ahead and keep going. Now with this, the process for multiplying these binomials is FOILing, okay? So let's try to multiply the binomials together. Let me fix this real quick. All right, so when we multiply the binomials, it's first outside, inside, last, okay? That's what FOIL stands for. So the first, when I multiply them, x times x is x squared, okay? Then when I multiply the outside terms, x times 2 is 2x. When I multiply the inside terms together, that gives me x. And when I multiply the last terms together, that gives me 2. All right, so hopefully that made sense. If not, we can pause the video. You guys can talk about it a little bit, but hopefully everybody's good on the algebra stuff, okay? So let's go ahead and keep going. This is going to be x squared plus 4x. And what I'm going to do is I'm going to combine like terms. So when I combine like terms here, 2x plus x is, you guessed it, 3x. And then plus 2. Okay, so we got to try to solve the equation. So what we can do is, well, we've got to try to get x by itself. But one thing I notice on both sides of this equation is that we have an x squared here and an x squared here. So what we can do to get rid of that is just subtract it from both sides. Okay, when we do that, those go away. And those cancel both sides. So this is going to be 4x is equal to 3x plus 2. Okay? And then from there, we can solve. So we've got to try to get x on its own side by itself. So let's subtract 3x from both sides. So x is going to equal 2. All right. So that's x. But guys, did we answer the question? That's the question you need to ask yourself. And the answer to that is no. Okay? We did not answer that. We did not answer the question. We found x, which is great. We're going to have to figure out what x is, so we got to plug it back in. Okay. So when we plug it back in, well, let's plug it into each one of them. So we said x was 2, right? So let's plug a 2 in there. So x times, or sorry, just x, 2. Okay, that guy's going to be x. No, sorry, it's going to be 2. When I plug a 2 in here, it's going to give me 6. When I plug a 2 into there, it's going to give me a 4. And when I plug a 2 in here, it's going to give me a 3. Okay. So, well, this actually might look a little familiar now. It looks pretty much like the last problem, except now we know what the measurements are. We had a bunch of variables here. So when we plug them in, well, to find ML, all we got to do is add those two together. Okay, these two segments, add them together. So 2 plus 6, so ML is going to be pretty easy, 8. Now, JK, when we add those two together, 4 plus 3, JK is going to end up being 7. So that's our answer there. Okay. So that is another example using that theorem that we just talked about. So again, to review, if we were to check that, actually let me check this real quick. So does this piece times this piece end up equaling this piece times this piece? The answer is yes. 2 times 6 is 12. 4 times 3 is 12. So that's the only thing we need to know about those chords intersecting in terms of the segment lengths. Okay? So again, that's what this is saying. Okay, that's what this theorem is saying right there. All right. So let's go ahead and keep going, guys. So what we're going to do next is we're going to look at actually some more terminology. Okay, so let me explain a few things first before we can get to the next couple things. All right. So what we're going to have to do, first of all, like I said, actually we're just going to talk about terminology here. So let's go ahead and label what this segment is. Okay, so I drew this segment or this picture here so you guys could see. I want to label a couple different things about it. So first of all, this right here, this entire segment is, since it cuts through the circle at 2 points, since it intersects it at 2 points, we've talked about this. Guys, what would that be called? Any line that cuts through the point at 2 different places. Okay, I meant to say any line that intersects the circle at 2 different places. Somebody in the second row, give me that answer. And I'll pause the video so we can give an answer. All right. If you said a secant segment, that is correct. All right, so here, this is a secant segment. So anything that cuts through the circle, anything that intersects the circle at 2 points is called a secant segment. All right, let's keep going. So that's what a secant segment is. Now, This segment right here, okay, it looks like it's only going to intersect it at one place. So you guys should know the answer to this. What is that called? Well, that's called a tangent. And since it's a segment, it's a tangent segment. Okay. And then the last thing, guys, we have this piece of this secant segment. I want to talk about what that's called, and it should make sense here. It's called the external segment. Okay, it's the external part of the secant segment. So this right here is the external segment. All right. So that's what we have. Those are the three things you're going to need to know for these next two theorems. All right, so make sure you guys understand these. We should know what secants and tangents are already. We're just calling them secant and tangent segments. Now the last thing, let me just draw it real quick. Let me highlight it. So this right here is going to be the external part of that secant segment. So that's the external segment. All right. So there's going to be an external segment to the secant segment, and then there's also the entire thing that we're going to talk about as well. All right, we'll get to that in the next theorem. All right. So in order to keep going here, we want to go ahead and write down the definition, or what the next theorem says. It's called the secant-secant segment theorem. It's fun to say, secant-secant segment theorem. So let's go ahead and fill in the blanks here to your guided notes. What it says is, I'll go ahead and read it. Okay, so this is kind of a mouthful. Hopefully it makes sense when I read this here. So what we're saying here is, if two secant segments share the same endpoint outside a circle, then the product of the lengths of one secant segment and its external segment equals the product of the lengths of the other secant segment and its external segment. All right, so guys, I know that's a lot to try to comprehend, but just try to fill in the blanks, and I'll give you guys an easy way to remember this here. All right, so let's go ahead and get started here. Hopefully you guys have the blanks filled in. And like I said, at any point, if you guys need to stop the video, just let Mr. Davison know. He'll stop it. He'll pause it for you, so you can get things written down. So let's go ahead and keep going here, guys. So we got A. We're going to call that A. We're going to call this E. We're going to call this C. This is going to be B. And this is going to be D. Okay. So an easy way to remember this, rather than having to remember all these words, and there's a lot of stuff here to try to process. What this is essentially saying. Okay, so let me just write this down. Easy way to remember. Okay. So the equation is going to look like this. It's going to be the whole thing, the whole secant segment, times the outside part is equal to the whole secant segment times the outside part. So we're talking about the other secant segment in this case. So the whole times the outside of the first secant is equal to the same thing as the whole times the outside of the second part. Okay? So another way of saying that in this example, okay, so we have this example, we have some things labeled. So what you need to ask, what I want to ask you guys is, what is the whole segment, let's say, of this secant segment? What would the whole thing be called? All right, so pause the video now and somebody answer in the third row. What would the whole segment be called? Okay, so if you said EA, that is incorrect. You're wrong. All right, but if you said EB, that is correct. So EB is the entire segment. Okay, it's the whole thing. And the outside part, I've already mentioned it, is EA. Okay, the external segment is EA. So what we're saying here is the whole times the outside. So EB times EA is going to equal the whole times the outside of this secant segment. So it's going to be ED times EC. All right, so hopefully that makes sense. That's what this theorem is saying. Whole times the outside is equal to whole times the outside. So I think that's a lot easier to remember than this whole thing. So that's what I would advise you guys try to remember here. So now remember, it is the whole thing. So that's what a lot of people mess up on. They just multiply the inside times the outside, or try something else. But it's the whole thing. It's going to be EB times EA is equal to ED times EC. So if that doesn't make a whole lot of sense, we're going to do an example, and hopefully it gets a little bit clearer when we actually throw some numbers in here. All right, so we're going to do a numeric example here. This is on your guided notes as well. So let's go ahead and keep going, and we'll see what we can get to. So find the value of x here. That's the goal. All right, so let's walk you through this. Actually, let's pause the video right now, and you guys try it on your own. You guys try to figure this one out. I know we haven't gone over one as a class, but let's see what you guys can do, and we'll talk about it. I'm about to go over it, so let's pause it and see what you guys can do. Okay, so let's go through this here. Tell you what, I don't have the answer right in front of me, so let's just go over here. I don't know what you guys answered, so let's see what we can get. So again, I'm going to write down the formula: whole times outside equals whole times outside. All right. So actually, guys, before I really get into this, this is the formula, yes, but you got to make sure you have the right types of segments. Okay. So what you need to ask yourself is, do I have two secant segments here? And the answer is yes. I've got two secant segments because this guy intersects the circle at 2 points. This guy intersects the circle at 2 points. So both of those are secants. So I need to use this equation. Okay. I need to use this formula. So let's see what we can do when we actually plug stuff in. So what you need to ask yourself is, let's start with this segment right here. What is the whole thing? All right? What is the entire length of that secant segment? Okay? Now, not the inside, I want the whole thing. So what is the entire thing here? Well, you should answer 9. Hopefully that makes sense. 5 plus 4 is 9. So the entire thing is 9. So it's going to be 9 times the outside. What's the outside part? You can answer
4.
Yep, 4. Oh. 4, nice job. So that's what a 9 times 4, okay, that's what we have. So that's the whole times the outside. And what is the whole times the outside down here? Well, here's what trips a lot of people up. So let me go ahead and talk about a common mistake that a lot of people make. The whole thing, from there to there, is not x. X is the inside part of that. It's not 3. 3 is the outside part. So what do we have to do to find the whole thing? Well, we have to add them together. And no, it's not 3x. Okay, that's a common mistake as well. It's x plus 3, or 3 plus x. So the whole thing here is going to be 3 plus x, or x plus 3, however you want to write it. And then, guys, what's the outside part? That should be pretty easy. The external segment is 3. So it's going to be 3 plus x times 3. All right, so try not to make those mistakes that I just talked about, and let's see what we can do to solve this. So 9 times 4 is going to be 36. Okay, now 3 plus x times 3. What do we have to do with this 3? You got it, distribute. Okay. So we got to distribute the 3. And so 3 times 3 is 9. 3 times x is 3x. All right. Then we got to subtract 9 from both sides to solve it. This is going to be 27 is equal to 3x. And then I'm going to divide by 3. So x is equal to 27 divided by 3, 9. Okay. X is equal to 9. Now, here's the question. Did we answer the question? The answer, yeah. It just says find the value of x, and we've got it. That's 9. Okay. So just to double check it, why not? Why not just double check it? So the whole, it's the whole times the outside is equal to the whole times the outside. So the whole thing here is 9. The outside part's 4. 9 times 4 we've already done, 36. Okay. The whole thing here is 12, because 9 plus 3 is 12. The outside part's 3, so 12 times 3 is 36. So it looks like it works out. We did it correctly. So hopefully that makes sense now. And like I said, this stuff right here, I know it's wordy, lengthy. That's the math speak for essentially this. I just try to give you this formula here, try to make more sense of it. So it's an easier way to remember. Whole times outside equals whole times the outside. Now this is only when we have two secants. That's why it's called the secant segment theorem. All right. Next theorem we're going to talk about is the secant tangent segment theorem. Okay. So let's go ahead and get into that. It's not much different. Hopefully it'll make sense as well. All right, so here goes. All right, so here's again, this is the mathematical definition or explanation of what the secant tangent segment theorem is. So notice what we have here, secant tangent. So we're going to have a secant segment, and we're also going to have a tangent segment. And I have a picture drawn down here. So try to fill in the blanks here to your guided notes, and we'll get started after this. So make sure you get the things you're missing there. And again, if you need to pause it, go ahead and pause it. But let's go ahead and keep going here. Now, so we've got AE is this segment, ECD, or actually we'll just call it ED is that segment. All right. So what we have here, EA, you need to think, what is that segment? What type of segment is it? Is it a tangent or is it a secant? Yeah, it's a tangent. Okay. So this is going to be a tangent segment. And this guy right here, you can tell it intersects 2 points, so it's going to be a secant segment. So that means we need to use this theorem. Okay, that's how we can figure out missing segment lengths. So let's go ahead and get started here. So what we're saying is, let me just go ahead and give you an explanation of what this is saying. Just an easy way to remember it. It's still the whole times the outside. Instead of equaling whole times the outside, guys, a tangent segment, all of it's outside. Okay, it's all the external segments. So the whole thing is EA, and the external segment is EA. So what do we get when we take EA times EA? Well, we can call that EA squared. Okay, EA, it's in the game, right? All right, so we got tangent squared. Nobody got that reference? It's EA Sports. It's in the game. All right, so whole times outside is equal to the tangent squared. All right, so that's the way we can remember the secant tangent segment theorem. So let me, in this case, let me just go over what this would mean in this picture. So what we would have, so the whole thing is going to be, for this secant segment, the whole thing is going to be ED times, the outside part is EC. So whole times outside is equal to the tangent segment squared. So it's going to be EA squared. Okay. So hopefully that makes sense. And we're going to try to do an example or two on this theorem. And this will be the last theorem we talk about. So let's go ahead and get to that. So here's our example. So if we want to find RS, my bad, we don't want to find RS. I messed that up. Let me fix this. We want to find STX. Yeah. I'll fix that. Okay, so find ST. All right, let's go ahead and go through this one together. Let's see what we can do. So, first of all, what I want to do is just realize what type of segments we have. Okay, what type of segments do we have here? So RQ, is that a secant segment or a tangent segment? Somebody in the third row, is that a secant segment or a tangent segment? Have I already called third row? Okay. All right, let's make it fourth row. Somebody in the fourth row, is that secant segment? Actually, not all my classes have fourth rows. First row, first row. Is this a secant or a tangent? I'll pause. It's a tangent. All right, intersects at one point. All right, so this right here is a secant segment because it intersects it at 2 points. So if we have that, well, let's use the secant tangent segment theorem because we got a secant and we got a tangent. All right, that's the one we need to use, the one we just talked about. So what that says is the whole thing times the outside equals what? Well, if you remember, tangent squared. All right, so let's go ahead and start plugging stuff in. So with our secant segment, what is the whole thing? Well, remember, I said this is a common mistake that people make. It is not x. X is not the entire thing. 8 is not the entire thing. The entire thing is 8 plus x. So it can be 8 plus x here. That's the whole secant segment. Now the outside part should be pretty easy. The outside part is going to be 8. So 8 plus x times 8. and that's going to equal the tangent squared, and the tangent is 16, and we got squared. There we go. All right, so let's see what we can do from here. So what I have to do is, well, the 8 here, I'm multiplying it to 8 plus x, so let's go ahead and distribute that. So 8 times 8 is 64. 8 times x is 8x. 16 squared, 256. 256. All right, let's solve it. So in order to solve it, you got to get x by itself. So let's get rid of this 64. So let's subtract it from both sides. So we got 8x. And that's equal to, what is that equal to, Mrs. Grigsby?
192.
192. Bingo. And then let's go ahead and solve. So we got to divide by 8. And so what's the final answer, Mrs. Grigsby?
24.
Okay. That's good. I was about to disown you if you didn't get it right. All right, so we've got that. X is equal to 24. And, okay, so that's what X is. So we've got it, and that's ST. So we've got our answer. We can just circle that, I guess, because that is what we wanted to find, ST. Okay. Okay, I'm going to stop right there. If you need to rewatch any of this, feel free to do so. There's plenty of, it's plenty of, there's plenty of time. There should be plenty of time left in the class period. So if you need to go back through any of that stuff, but really guys, let's just review what we talked about. Okay, so really quickly, this is what Mrs. Grigsby went over with you guys. That if we have two chords, if they intersect in the interior of a circle, then the product of the lengths of the segments of one chord equals the product of the lengths of the segments of the other chord. So, long story short, this piece times this piece equals this piece times this piece. Okay, so let's keep going. Let's go over this secant segment theorem. Easy way to remember it, whole times outside equals whole times outside. All right, so you just take the entire thing times this part, entire thing times this part, set them equal. Okay? That's what we can do to solve there. And then the last thing, secant tangent segment theorem. It's very similar to the secant segment theorem. It's just going to be whole times outside equals tangent squared. Okay, now if you have any questions, you're on your own because I'm not here. Okay, so just like I said, look back at the videos if you have any questions. If you still have questions, I'll be here next week on Monday, so we'll answer any questions you have.
Bye guys, good luck!